Hello class. Today we'll be learning about different types of variations. There's 3 types of variation. Let's get into it. The first one is direct variation. We start off with our base equation as y equals kx. Example. If y varies directly as x and x equals 7, solve for y. We'll start off with the equation to give us y equals 3k. We know what k will be, it's 7. So we sub 7 in for k, and it'd be y equals 3 times 7. You'll get y equals 21. Using a proportion. This whole chapter is based off fractions. So let's just get into it. We'll start with 2 equations. y1 equals kx1 and y2 equals kx2. Get k's on the outside so you can cross them out. You'll end up with y1 over x1 equals y2 over x2. Example. If y varies directly as x and y equals 15 when x equals negative 5, find y when x equals 7. We'll start off with our equation. y1 over x1 equals y2 over x2. Sub in y1 for 15, negative 5 for x1 equals y2, since that's what we're solving for. x2 will be 7. Cross multiply and you'll get 105 equals negative 5y2. Divide by negative 5, you get negative 21 equals y2. The second type of variation we'll be learning about today, joint variation. Once again, our base equation will be y equals kxz. Now, we added a new variable, z, so be on the watch out. Example. Solve for y when x equals 6 and z equals negative 2. The equation they give us is y equals 5kz. Y equals 5 times 6 times negative 2. Y equals negative 60. Once again, using a proportion. We'll start with our 2 equations. y1 equals kx1, z1, and y2 equals kx2, z2. Get the k's on the outside so you can cross them out, and you'll end up with y1 over x1, z1 equals y2 over x2, z2. Example. Find y when x equals 9 and z equals 2. If y equals 20 when z equals 3 and x equals 5. We'll start with our equation. y1 over x1 z1 equals y2 over x2 z2. For y1, we'll put 20 in. For x1, we'll put 5 in. For z1, we'll put 3 in. For y2, we'll leave blank since that's what we're solving for. For x2, we'll put 9 in. For z2, we will put 2 in. Cross multiply the basics of fractions, and you get 360 equals 15y2. We'll divide by 15, and y2 equals 24. Third type of variation we'll be learning today, inverse variation. There's 2 different types of base equations we can have. xy equals k or y equals k over x. There's 2 equations because it depends if you want y on the outside or k on the outside. Example. Find x when y equals 1/3. The equation they give us is xy equals 2. So they used the first type of equation and had 2bk on the outside. We'll sub in 1/3, and you get x times 1/3 equals 2. Multiply, x equals 6. Once again, a proportion. x1, y1 equals k, and x2, y2 equals k. Cancel out the k's, you'll get x1 over y2 equals x2, y1. For this one, we do not have the z. Example, if x varies inversely as y and x equals 28 when y equals -2, find x when y equals -10. We'll start off with our equation. x1 over y2 equals x2, y1. 728 for x1, -10 for y2, x2 blank over -2. Cross multiply, -56 equals -10x2. Divide by -10, x2 equals 5.6 or 5 3/3. Ms. DeBellis doesn't care if it's in decimals or fractions, but it's always to put both just in case. Our last variation we'll be learning is combined variation. This involves all the variations we learn, so direct, inverse, and joint variations. We'll start off with two equations. y1 equals kx1 over z1, and y2 equals kx2 over z2. Get the k's on the outside, cross them out, and then you'll end up with y1 z1 over x1 equals y2 z2 over x2. Example, suppose f varies directly as g and f varies inversely as h. Find g when f equals 18, h equals -3, and g equals 24, when h equals 2 and f equals 6. Remember, we'll start off with our two equations. f1 equals kg1 over h1, and f2 equals kg2 over h2. You can see we subbed in the variables for f, g, and h because in the example problem, they gave us f, g, and h, and we didn't want to confuse you with k and z, x and z. Get k on the outside, cancel them out. f1, h1 over g1 equals f2, h2 over g2. Sub 6 for f1, 2 for h1, 24 for g1 equals 18 for f2, -3 for h2 over g2, since we're solving for g2. Cross multiply, get 12g2 equals -1,296. Divide by 12, g2 equals -108. Real world example. The length of a violin string varies inversely as the frequency of its vibrations. A violin string is 10 inches long. Vibrates at a frequency of 512 cycles per second. Find the frequency of an 8-inch violin string. Let V1 equal 10, F1 equal 512, and V2 equal 8. Solve for F2. V1 F1 equals V2 F2. 10 times 512 equals 8 times F2. Cross multiply, then divide by 8 to get F2 alone. You get 5,120 divided by 8 equals 640 F2. Those are variation functions, section 8.5. I hope this helped you a lot to understand variation functions. Stick around for example problems because you will be getting candy if you solve it correct.